do you think this is a LL1 parser, is suitable for LL1 parser or top-down predictive parser? Is it suitable or not? William said it's not suitable. Any reason for that? Ah, that's very good. Awesome. Thank you, William. Awesome. That's part of the reason. Part of the reason. At least it's a very good first step, absolutely. I can tell you the tricky part here. Of course, if it is, when you show it, of course, you may want to say, okay, that one has no left recursion. That one has no need for left factoring because there's no common prefix. And also, you want to show that, remember that little property we talked about, the star symbol for every pairwise alternative rule should have no intersection. These are the three things you want to check. Right? I'll get there. Either you have to show that they all satisfy, or if you got any violation, for example, as William said, you got left recursion. By the way, is it direct or indirect in this case? Direct, right? Because you got R here, R here. That was obvious. So, and the funny thing is, once you fix this guy over here, well, of course, you can see the common prefix right away over here. So it's kind of up to you which one you want to fix first. Doesn't really matter. In theory, it's actually possible maybe once you fix something here, you might have something else that come up as problematic. So you're going to keep checking. It's more like an iterative process until there's no problem. Right? That's the overall thing you have to do. All right, good. Okay, so this is basically the question here. The actual correct answer, if you ever try, it should be if not. Okay? We want to identify the problems, and then we may fix them whenever possible. And when we say fix, that means you shouldn't really change the semantics. You may want to eliminate recursion. You may actually want to eliminate common prefix, but you cannot change the meaning of the grammar. That's the bottom line. Okay? So let's see what the problems are. All right, this is the slide that you're supposed to recall, but I'm just putting that here so when you study for this example, you can just recall yourself. And of course, you have to be no left recursion, right? Should be nothing there, but it does have, so that's why it violates. And also, there should be no need for left factoring because you got common prefix, but we need to fix that too. And this is also the property you have to check. Okay, that's something we will also check. Because ultimately, how do you say there'll be no more fix needed for the grammar? You want to say, because after fix number 1, after fix number 2, this property is actually satisfied. In that case, I don't need to go any further. So that will be suitable for the top-down parser. All right. I do have the solution over here. I'll make it available to you today, but I think it might be nice to go over the step with you together, right? Quickly, and then we're done. Okay. Let me start with, again, this guy over here. Okay, if you don't mind, let me do some quick trick. Okay, and then just get a grammar. Done. Okay, that's the input grammar. Okay. And as we said, that one has left recursion. Direct. Left recursion. Okay, and how do we fix this? Do you guys remember where you should really look into? Do you remember? Okay, let me give you a little bit of hints quickly. Okay, if I go back to the slides, I believe in one of the topics is about eliminating. I'll show you what you should look at, and I'll give you the answer so we can save some time. If you actually go back to, sorry, that's too far. Before we talk about the first, here. Right? If you remember this algorithm about removing the left recursion, this part over here, the green one, is about removing indirect left recursion. What we need is the red part over here, the pattern. Okay? Just remember. And how do we do it? Okay? So what we want to do is we want to remove the left recursion of this guy over here. And if you think about it, what's going to be the pattern like for the string? It's actually going, you can think about this and this. These are like a base cases for the rule. You can have as many BC as you like, as many BC like that as you like, And then eventually you're going to replace this part here either by ABA or CABA. Agree? That's the pattern. Okay? And the corresponding right recursive grammar production rule. I'm going to put it on here. Tell me if you're convinced. Okay? I'm just going to put it here. And I'm just going to follow actually the naming conversion from the algorithm. So since I got R here, I'm going to introduce another rule called R prime. Okay? So I'm going to put it here. So that's going to be R produces. So I'm going to put base case, two base cases. So ABA and CABA. And then they're going to be followed by the new variable I'm going to introduce. Okay? And R prime is actually going to be here. And then I'm actually going to put, what will be R prime? That one will have to do with the recursive case. It's going to be BC and then R prime. Am I missing something here? Henry. Thank you. You read my mind. There we go. Yes. That'll be the right recursive version. Very mechanical. Okay? Oh, guys, there's one thing just came to my mind. I think for the exam, I'm quite flexible to take either a version of the exam. You guys want to bring cheat sheets to the exam, or you want to have a version of the exam without the cheat sheets. Right? You guys can think about it, because I can tell you that I don't have any past exam, because the last time we ran this course, we actually got locked down, on the final part of the course in the winter 2020. So I actually gave students around that time a choice whether they want to have like a 30% exam, or do they want a 70% project. All of them chose 70% project. So we didn't have an exam. So, well, 70% sounds okay, right? 70%, 70, not 17. Anyway, so I don't really have an exam just yet. So I'll be more than happy to hear you guys' thought. If you really want a cheat sheets, then the exam question might be slightly different. If you don't have a cheat sheet, this exam may be designed accordingly. That's something you think about it. I can follow up with you maybe next week. Think about it. Okay. Of course, cheat sheets, both sides, handwritten or computer type, no magnifier. As long as you can read it, I don't care how small it is. No magnifier. Don't bring it. All right, that's the first part. So this will be fix number one. Fix number one, remove left recursion. Okay. So now, after this has been done, so what will be the new grammar? The new grammar is actually going to be like this. Okay, I'm going to put, we're going to do two fixes on the same page. The new grammar looks like this. Or QBA. And also we got this one R, ABA, R prime, CABA, R prime, produces BC R prime, or epsilon. Finally, we got Q produces BBC or BC. That's the fixed grammar. Okay? Is this grammar now ready for LL1 parser? It turns out it is not, right? And I'll refer you to something you can definitely look into on the slides, and then I will show you how you can fix for this one, right? It's a nice review for maybe for your quiz number 5. If you actually go back to the left factoring over here, if you remember the way, oh, sorry, not this one, the previous one, slide 52. If you remember the way we introduced left factoring, let's say we consider this grammar, which has the same problem as the grammar that we just have right now after removing the left recursion. As Henry said, I believe, last time, for this particular rule, because it would be ambiguous for you to know which one to choose. Because if the next word to match would be the name, you can either choose this one here, or this one here, or this one here. So they got some common prefix. So the way to fix it is by factoring out. It's called left factoring. If you actually got ambiguity in this way, like their first symbol actually overlap, in that way you're violating the property over here, right? Over here. Okay, just remember. So what I would do is I want to do one more thing for you. So this part over here is problematic. This part over here, problematic. And we want to fix it. Problematic. And this would be what you have to, actually, bear with me. This will be what you have to recall. There we go. Okay, I'll put it here. So when you check it, you have to make sure you check with that. Because the start for these two rules is going to overlap on the symbol B. Okay, that's briefly speaking. Okay, good. That's all good. And how do we fix it? Let's fix that quickly. So let me move to the next page. What I will need to have is this guy here. Okay, let's go to this page. Continue with this. And then let me just wipe this out. The idea would be very simple. You will just have to make sure you find out the common prefix, which is this part, and factor that out into a new variable right-hand side, basically. Okay, I'm going to write it down for you. And of course, make sure you go over other example too. This one here, we're going to do left factoring. And what you will see on the solution will be something like this. You're going to see Q produces, because this is a common prefix, so put it here still. And then the rest will be Q prime. Right? And then Q prime produces either this or this. And as you can see, no common prefix for this one because it's only a single rule. Also, no common prefix for this one here. You can see B versus C, right? It's okay. So the new grammar is 1, 2, 3, and 4. That's all we have. And the final step. Oh, actually, by the way, before I say anything, do you think right now we are okay? What do you have to check if you want to make sure this is okay? Number one, you want to make sure left recursion is absent. Number two, no common prefix. What else do you have to check? I can tell you these two problems are gone away. They are not there anymore. But there's one more thing you have to also show as part of the answer. That's the tricky part. Okay? You want to somehow show that this revised grammar, this and this one here, together satisfy this property here. How do you show? There are different ways to actually show. I found maybe the most convenient way also for you to write down is to use a table. I'm going to structure the table on the page, give you some idea. I'll fill out some entries together with you, and then you will work out the solution. Okay? This will be the final step. Let me just try to copy this guy here. That will be number 3. All right? So these are the 3 things you want to check. All right? Let's now take a look. What I need to do is, let me just copy this guy here. I'll just open a final page. And then, what's the grammar we have? Good. This will be the final grammar we got to consider to justify that it satisfies that formal property. Color, what about green? Okay, this will be the final grammar to consider together. And then this will be the table you have to draw. like this. I would suggest we start with a column called non-terminal or variable. Okay, that'll be the first column. And then we have another column called what are the different alternatives. For example, you have to, for the non-terminal, it's going to be L, R, R prime, Q, and Q prime. Under L, you have two rows, either alternative number 1 or alternative number 2. And then you're going to argue that for these two alternatives, their star symbol do not overlap. And you're going to argue that for every non-terminal, basically. Okay? And then for every alternative, you also need to calculate their start set. And I insist I should really show you very quickly about where the start set is. That's also a slide you want to make sure you also go over. Of course, the computation for the first set is based on both the first and follow. Okay, maybe this here. Maybe I have gone too far. For the calculation for the first set, please go to slide. Okay, I'm pretty sure it's in the earlier one. Almost there. There we go. Here, slide 50. All right, that's how you calculate start. And to calculate the start, of course, you have to know how to calculate first and first union follow. Okay, make sure you review that too. All right, so you're going to calculate first set, and then you want to show if there's any intersection. And let's do a few together. And then I'll leave the rest to you. Okay? How about we start with something very simple? Of course, the order in which you actually list the non-terminal is completely up to you. Okay? Why don't I start with this one? Why? Because this one is actually rather simple. It has only terminals over here. Right? Why don't we do that? Okay, and you'll see the idea. Let's say non-terminal I'm trying to compare will be Q prime. And it has two alternatives. Either it has the BC or it has the C. Now, what would be the start set for this alternative? And what would be the start set for this particular alternative? Anyone? Well, I would say this case are simple, right? Because you kind of run into the wall right away, just a terminal. So that terminal should be just the first. There's no need to consider follow, right? That's a simple case. All right, so here you got B here, a set. Here you got C here. What's the intersection? Empty. All right? So far, so good. Okay, of course, you don't need to be that fancy when you draw this table, but just want to make sure you're fine. That's the first non-terminal. Let's do at least another one. Okay? What about, actually Q is actually rather simple. Okay? What about R? Let me see, R prime. How about we do R? Okay, R is also very simple. How about do R? Okay, let's do R. We have 1 and 2 alternatives. ABA, R prime, also CABA, R prime. All right, so that's what we are considering over here, R. Okay, and then this one is also can be done very straightforwardly, right? What will be the start set for this alternative? Zuka. You know what? Just A. Because once you hit A, you cannot see B anymore, right? Once you see the terminal, it's done. Okay, just remember, not ABA. I'm glad you actually said that. And what about this one? Nicholas? You want to? Absolutely. Thank you. Empty, right? Good. And guys, I think it would be worthwhile for you to work out the rest. I'll put it here. And I'm going to make the solution available on the e-class today maybe a little bit later. So definitely do that, and then you can check. What's really remaining? We still got L, we still got R prime, and also we got Q, right? So this will be a very systematic way to make sure you can argue that your grammar actually satisfy this particular property. And one thing, I'm not sure if I gave you that impression. If that's the case, it's definitely not the case. This is telling you you're not really trying to compare production rule across the variable. For example, you wouldn't really compare, let's say, this rule and this rule. Why? Because the idea about calculating the start set is to say when you actually got this one to get reduced into, you want to consider either this or this. If their start set do not really overlap, then you have no trouble. So comparing, let's say, alternative from different variables doesn't really make sense, right? You wouldn't try to reduce the same different variables at the same time, okay? Just clarify, just in case. All right, so I think that this will be a very nice exercise to review what we have done, but make sure you also study other parts too. They could also be on the quiz. And also, it's worthwhile to go over your exam too. I mean, to study your exam. Any question about this? Robbie? Oh, are you talking about, okay, I see what you mean. Are you talking about Q here? Yeah. Yes, absolutely. That's a very good question. If you think about it, this property here is kind of interesting. You know what? Let me put it here. So guys, Robbie asked a very good question. The question goes like this. What about this non-terminal, which has only one alternative? How do we argue that this actually satisfies that? Before I point to William, this may have to do with your 1090. Oh, is that what you're thinking about or no? Okay. Or let me make it a little bit more explicit for you. To argue that this guy here actually satisfies this, you may have to argue some property about universal quantification. When, okay, brilliant, go ahead.
So it's true because basically I have to check all the possibilities of I and j, and there aren't any possible I and j that don't equal each other.
That's very good. So, very good. So that, well, if you look at this guy over here against, oh, somebody. It was somebody, right? It's not my illusion. Okay, good. Over here, yep. How do you check? So there is no such I and j that are not equal to each other. So that means this range over here is simply just false. When you have a false range for universal quantification, that's to say, well, let's say you have an empty set. You say every element in the empty set is larger than 0. It will be true because you cannot find any witness which will violate that property. Agree? So, true, trivially. So Robbie, so that's your answer. So in this case, if you only got one alternative over there, it's true trivially. But that's the reason. Okay?
Yeah, but you gotta write that.
For this one here, you don't, I think, yeah, this one is a bit tricky. So I think you can still write it. You can still write the alternative over there to say for Q, it only has one alternative. There's no intersection. In some ways, like an empty set. But you can also say there's only one alternative, so there's no way for you to have two alternatives that actually got the same start set. So it's not possible. Yeah. So that's why you have to explain in detail. Right.